So we are dealing with the 16th problem in this series, and the 16th problem in this series is problem number 1.107. The problem is stating a chain of length L is placed on a smooth spherical surface of radius r with one of its ends fixed at the top of the sphere. What will be the acceleration A of each element of the chain when its upper end is released? It is assumed that the length of the chain is L, which is less than pi r by 2. So as we approach this problem, let us first understand this situation by drawing a necessary diagram. So this is how we can explain the situation which is given in the problem. This is the topmost point about which the chain is released, and it will start sliding down this smooth surface. So now over here, let us consider at an angle theta a patch of d theta. So at this angle theta, we are considering a patch of d theta which is having a mass segment dm. So it is having a mass segment dm, and we consider that this total angle with this chain subtend is phi. So over here, the first thing that we do is we calculate the mass m. So over here we are using lambda, that is mass per unit length. So mass per unit length being L, this is equal to dm upon. Now this distance is equal to r d theta, where r being radius. So therefore over here we can calculate the dm. So dm can be written as m by L r d theta. Now this dm patch is going to experience a force, which is the tangential force, which we are marking as ft, and ft can be calculated in this way, that over here the weight dmg will act in the downward direction. So if this angle is theta, this one is also theta, so this is 90 minus theta, so dmg cos 90 minus theta, dmg cos 90 minus theta, that is sin theta. So over here the tangential component of force on this small mass segment can be written as m by L gr sin theta d theta, and if we integrate this expression, then we will get the tangential acceleration. So over here if we integrate this expression, because m, g, r and L are constant, so we are integrating this expression for the values of phi. So if we look at the values of phi, so if we reach the highest point, the value of phi is 0, and at this point, so over here if we calculate the total angle which it subtends, so angle phi is going to be arc length upon radius, where arc length is L by r. So from 0 to angle phi is the limit of integration, and over here we write it as m at equals m by L gr, and integration of sin theta can be solved over here as 1 minus cos of phi can be written as L by r. So if we remove m, so we get the tangential component of acceleration at, which is equal to gr by L 1 minus cos of L by r. So this is the final answer for this problem, which is asking us to calculate the tangential acceleration of a point on the chain as it is sliding down. So this is how we solve for the tangential acceleration.